Hello everyone, welcome to the Prime Math Lovers YouTube channel. This video is part 2 of the Ultimate Algebra Exam. It covers questions 21 through 40 and is part of a series tailored for those preparing for their Algebra final exam. It marks the continuation of the Algebra exam consisting of 40 questions with detailed answers. As mentioned, in this segment, we'll address problems 21 through 40. For each problem, I suggest pausing the video to solve it independently. Afterwards, resume the video to check your answer. Question 21. The area of this triangle is 24 square centimeter. Calculate the perimeter of the triangle. So the base is 6 centimeter. The height is 3x minus 1 and hypotenuse is 3x plus 1. This is a right-angled triangle. We know the formula of the area of triangle is 1 over 2 times base times height. Base is 6 centimeter, height is 3x minus 1, and the area is 24. So 24 is equal to 1 over 2 times 6 times 3x minus 1. 6 divided by 2 is 3, so 24 is equal to 3 times 3x minus 1. We divide both sides by 3 again, so 24 divided by 3 is equal to 3 times 3x minus 1 divided by 3. This 3 cancels this 3, and 24 divided by 3 is 8. So 3x minus 1 is equal to 8. We take this negative 1 to the other side, and it becomes positive 1. So 3x is equal to 8 plus 1. 8 plus 1 is 9. 3x is equal to 9. We divide both sides by 3. So 3x over 3 is equal to 9 over 3. And 9 over 3, or 9 divided by 3, is 3. So x is equal to 3. Now we can calculate the perimeter of the triangle by summing the lengths of all these sides. So perimeter of the triangle is equal to 6 plus 3x minus 1 plus 3x plus 1. This negative 1 cancels this positive 1, and 3x plus 3x will be 6x. So this is equal to 6 plus 6x, and if we replace x with 3, we will have x is equal to 6 plus 6 times 3. 6 times 3 is 18, and 18 plus 6 is 24. So perimeter of the triangle is equal to 24 centimeter. Question 22. Solve the equation x plus 2 minus 15 over x is equal to 0. To solve this equation, we first multiply both sides of the equation by x, and we get x squared plus 2x minus 15 is equal to 0. Now the equation is in the form of quadratic equation. For solving quadratic equation, with factoring method, first we multiply the coefficients of x squared, which is 1, with the constant terms, which is negative 15. 1 times negative 15 is equal to negative 15. Then we write down all the factors of negative 15. The factors of negative 15 are 1 times negative 15, negative 1 times 15, 3 times negative 5, negative 5 times 5, negative 3 times 5. Now we need to find two numbers from these factors that when we add them together, we get the coefficients of x, which is positive 2. These numbers are negative 3 and positive 5. Negative 3 plus 5 is equal to 2. We rewrite the middle term 2x as negative 3x plus 5x. And we get x squared negative 3x plus 5x minus 15 is equal to 0. Group the terms into two pairs, x squared minus 3x and 5x minus 15. Then factor out the greatest common factor from each pair separately. From first pair, we factor out x and we get x times x minus 3. From the second pair, we factor out 5 and we get 5 times x minus 3. Now we can finally factor out x minus 3 and we get x minus 3 times x plus 3 is equal to 0. When we have two factors multiplied together resulting in 0, it implies that each individual factor should be set equal to 0. We have x minus 3 is equal to 0 or x plus 5 is equal to 0. If x minus 3 is equal to 0, it means x is equal to 3. And x plus 5 is equal to 0 means x is equal to minus 5. So 3 and minus 5 are the roots of this second degree equation. Question 23. The difference between two numbers is 7 and the sum of two numbers is 15. Find the values of the two numbers. Let x and y be the two numbers. Given the difference between the two numbers is 7, so x minus y is equal to 7, and sum of two numbers is 15, so x plus y is equal to 15. This is in the form of a system of two equations. For solving this type of simultaneous equations, we can use elimination method. In the elimination method, our aim is to eliminate one of the variables from the system of equations. Let's choose to eliminate y. In the first equations, the coefficients of y is negative 1. And in the second equation, it is positive 1. If we add these two equations together, negative 1 from the first equations cancels out the positive y term in the second equations. So we add these two equations together. As I said, negative y and positive y will cancel. X plus x is equal to 2x. 7 plus 15 is equal to 22, sorry. 2x is equal to 22. I can divide both sides by 2 and cancel 2 in numerator and denominator, and x is equal to 22 divided by 2, or x is equal to 11. Now we replace x with 11 into one of the original equations. Let's use the first one. X minus y is equal to 7. We replace x with 11, so 11 minus y is equal to 7. We take y to the right hand side and 7 to the left hand side. So 11 minus 7 is equal to y, or y is equal to 4. Question 24. At the fair show, the Bronson's family purchased 2 adult tickets and 3 child tickets for $48. The Burton's family purchased 3 adult tickets and 1 child ticket for $44. Calculate the cost for a child ticket and for an adult ticket. Let's call child ticket price x and adult ticket price y. So x is equal to child ticket price and y is equal to adult ticket price. Bronson's family purchased 2 adult tickets and 3 child tickets for $48. I can write down 3x plus 2y is equal to 48. X is child ticket price and y is adult ticket price. So 2 adult tickets, 2y, plus 3 child tickets, 3x. The Burton's family, on the other hand, purchased 3 adult tickets and 1 child ticket for $44. So I write down x plus 3y is equal to 44. 1 child ticket and 3 adult tickets. Now we have a system of 2 equations or 2 simultaneous equations. Like previous question, we use elimination method. In the elimination method, our aim is to eliminate one of the variables from the system of equations. Let's choose to eliminate y. In the first equation, the coefficients of y is 2, and in the second equation is 3. To make these coefficients opposites, we multiply the first equations by 2. We multiply, the first equations by plus 3 and the second equations by negative 2. So we get these equations times plus 3 will be 9x plus 6y is equal to 144. And the second equations times negative 2, we get negative 2x, negative 6y is equal to negative 88. If we add these two equations together, the positive 6y from the first equation cancels out the negative 6y term in the second equations, leaving us 9x minus 2x is equal to 7x is equal to 144 minus 88, which is 56. So we have 7x is equal to 56. Dividing both sides by 7, and we cancel this 7 with this one, and x is equal to 8. Now we replace x with 8 in one of the original equations. Let's use the first one. 3x plus 2y is equal to 48. I replace x with 8. So 3 times 8 plus 2y is equal to 48. 3 times 8 is 24. 24 plus 2y is equal to 48. I take 24 to the other side of the equation, so I get 2y is equal to 48 minus 24, which is 24 again. 2y is equal to 24. I divide both sides by 2, and I get y is equal to 12. So child ticket price is $8, and adult ticket price is $12. Question 25. Which of these lines is parallel to the line 3y is equal to x plus 5? For solving this problem, first we need to convert the line equations into the slope-intercept form, which is y is equal to mx plus b. M is the slope, and b is y-intercept. So we have 3y is equal to x plus 5. We can isolate y by dividing both sides by 3, and we get y is equal to 1/3 of x plus 5 over 3. And when we now comparing this with the slope-intercept form, we get we can see that slope of our line is 1/3, and the y-intercept b is 5/3. Parallel lines have identical slope, meaning that lines that are parallel will have the same slope value. In the given equation, 3y is equal to x plus 5, the slope is 1/3. Thus, the equation in the option B is the only one that shares this slope value, 1/3. Consequently, option B is the correct answer. Question 26. Graph the quadratic function of f of x is equal to x squared minus 2x minus 3. In this type of questions, for drawing the graph, we need to identify the key features of this function first. The first key feature is vertex. Vertex of a quadratic function is the point where the graph changes direction. In a quadratic function of f of x is equal to ax squared plus bx plus c, we can find vertex can be found using the formula of x is equal to negative b over 2a. b is coefficients of x, and a is coefficients of x squared. So x is equal to b in our function is -2 and a is 1. So negative 2 over 2 times 1. This negative cancels the other negative. So 2 divided by 2 is 1. So x for the vertex is 1. And then substituting this value into the function to find the corresponding y value. It means the y of the vertex is equal to f of 1. Means we replace x with 1 is equal to 1 squared minus 2 times 1 minus 3. 1 minus 2 is minus -1. -1 minus 3 is -4. So the graph's vertex is the point of, with the coordinates of 1 and -4. The other key feature is axis of symmetry. Axis of symmetry is a vertical line that passes through the vertex. So because it's a vertical line, we can show it with x is equal to something, and because it passes the vertex, and the vertex x on the vertex is 1, so axis of symmetry is x is equal to 1 in our equation. Y-axis, x-axis, grids. So vertex is 1 and -4. This is the point of vertex for our graph. And axis of symmetry passes, a vertical line passes this point. So it will be this line, and the equation for this line is x is equal to 1. The next key feature is y-intercept. Y-intercept is the point where the graph intersects the y-axis. To find it, we set x is equal to 0. So y is equal to f of 0. We replace x with 0, so it will be 0 minus 3. And y-intercept will be -3. So this point is our y-intercept, -3 on y-axis. The other key feature is x-intercepts. X-intercepts is the point or points that the graph intersects the x-axis. And this can be found by solving the quadratic equation of f of x is equal to 0. So f of x is equal to 0 means x squared, or f of x is x squared minus 2x minus 3 is equal to 0. And for solving this quadratic equation, we use the quadratic formula. It states that for equation ax squared plus bx plus c is equal to 0, x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. In our equation, a is 1, b is -2, and c is -3. So x is equal to -2b plus or minus b squared -2 squared minus 4 times a, 1 times c, -3, over 2a, 2 times 1, a is 1. So -2 will be 2, minus 2 squared is 4, -4 times -3 is +14. 4 plus positive 12, sorry. 4 plus 12 will be 16, so 2 plus or minus square root of 16 over 2, and square root of 16 is 4, so it will be 2 plus or minus 4 over 2. 2 minus 4 over 2 means x is equal to -2 over 2 or -1, and 2 plus 4 over 2 means 6 over 2, or x is equal to 3. X is equal to 1 is this point, and the other answer, x is equal to 3, is this point. Our graph passes all these 4 points, and the other key feature is direction of opening. A quadratic function can open upwards or downwards. If the coefficients of x squared is positive, it means that graph opens upwards. And if the coefficients of x squared is negative, then it means that the graph opens downward. In our equation, the coefficients of x squared is positive 1. So it is positive and the graph opens upward. And when graph opens upward, means the vertex point is the minimum point. So our graph is, vertex point is the minimum point, and our graph will be like this. Question 27. Find the minimum value of the function f of x is equal to x squared plus 4x plus 3. In a quadratic function, f of x is equal to ax squared plus bx plus c. If a is positive, the function has a minimum point. And if a is negative, the function has a maximum point. Since in our function, a is equal to positive 1, which is a positive number, our graph of this function opens upward and the vertex is the minimum point. The vertex is the minimum maximum point of the function. Therefore, the simplest way to find the minimum of this function is by determining its vertex. The vertex can be found using the formula x of vertex is equal to negative b over 2a. b in our equation is 4 and a is 1. So it will be negative 4 over 2 times 1 or negative 2. So x of v is, or x of vertex is negative 2. Then we calculate the y of vertex, which is the minimum value of the function. For doing this, we replace x in our function by x of vertex, which is negative 2. So we need to calculate f of negative 2. We replace x with negative 2, will be negative 2 squared, negative 2 squared plus 4 times negative 2 plus 3. So, or negative 2 squared will be 4 minus 8 plus 3, or is equal to minus 1. So the vertex of parabola is at point of negative 2 and negative 1. And the minimum value of the function f of x is equal to x squared plus 4x plus 3 is negative 1. Question 28. We have a circle x squared plus y squared is equal to 25. There is a tangent line to this circle at point 3 and negative 4. Determine the equation of the line. We have a circle. The given equation represents a circle with the with center at the origin 0 and 0 and the radius of 5. This 25 means that the radius of the circle is 5. First, we calculate the slope of radius, this radius. For calculating the slope of any line, we need 2 points of that line. So one point is the tangency point, which is 3 and negative 4. And one point is the center of the circle, which is 0 and 0. So y2 is negative 4, x2 is 3, y1 is 0, and x1 is 0. So m of radius, slope of the radius is equal to negative 4, negative 0 over 3 minus 0. And this will be equal to negative 4 over 3. The radius from the center of the circle to the point of tangency is at a right angle to the tangent line. Therefore, the slope of the this radius is the negative inverse of the slope of the tangent line. The slope of the radius is negative 4 over 3. So we calculate slope of the tangent is equal to negative 1 over slope of the radius, or is equal to negative 1 over negative 4 over 3. This negative and this negative can cancel each other, and 1 over 4 over 3 will be equal to 3 over 4. So we have the tangent of the, we have the slope of the tangent line. We can use the point slope form of the equation of a line to find the equation of the tangent line. The point slope form of an equation of a line is y minus y2 is equal to m times x minus x2. y2 and x2 is a point on the line, and m is the slope. We have the slope, which is 3 over 4. And also we have a point on the line, which is the tangency point, 3 and negative 4. So y2 is negative 4, x2 is 3, and m is 3 over 4. So we can write y minus negative 4 is equal to 3 over 2 times x minus 3. Or we can simplify, negative and negative will be positive. Y plus 4 is equal to 3 over 4x. We expand it, minus 9 over 4. Or y is equal to 3 over 4x minus 9 over 4 minus 4. We can take minus to the other side and the sign will be negative. Or y is equal to 3 over 4x minus 9 over 4 minus 16 over 4. I rewrite 4 as 16 over 4 to have the common denominator between these two constant numbers. And if we add these two numbers, it will be 3 over 2x minus 9 minus 16 will be minus 25. So y is equal to 3 over 4x minus 25 over 4. And if I multiply both sides by 4, we get a similar, we get a simpler form of the equation. And the equation of the tangent line is 4y is equal to 3x minus 25. Question 29. Victoria has a box of chocolates containing 10 identical chocolates. The total weight of the box and chocolates is 270 grams. Victoria eats 5 chocolates and the total weight of the box and chocolates decreases to 195 grams. What's the weight of the box? First, we need to find the weight of one chocolate. Let's denote the weight of empty box as B and weight of one chocolate as C. So C is equal weight of each chocolate and B is equal the weight of the empty box. Now we can set up equation based on the given information. 10 identical chocolates plus the box is 270 grams. So we get 10C plus B is equal to 270. And after Victoria eats 5 chocolate, we have only 5 chocolate plus the box. So 5 chocolate plus the box is equal to 195 grams. So now we have a system of two equations. For solving system of two equations, we can use elimination method. In the elimination method, our aim is to eliminate one of the variables from the system of equations. Let's choose to eliminate B in both equations. The coefficients of B in both equations is plus 1 or positive 1. To make these coefficients opposites, we multiply the second equations by negative 1, resulting in 10C plus B is equal to 270, and minus 5c minus b is equal to minus 195. Then we add these two equations together. The plus b from the first equations cancels the negative b in the second equation, leaving us 10c minus 5c is equal to 270 minus 195, or 5c is equal to 75. And if we dividing both sides by 5, we get 5c over c is equal to 75 divided by 5. This 5 cancels the other 5, and c is equal to 75 divided by 5, or 15. Means each chocolate weight is 15 grams. Now we replace c with 15 into one of the original equations. Let's use the first one. So we get 10 times 15 plus b is equal to 270. We use these equations and replace c with 15. 10 times 15 will be 150 plus b is equal to 270. We take 150 to the other side, so b is equal to 270 minus 150, and 270 minus 150 will be 120. So the weight of each chocolate is 15 grams, and weight of the empty box is 120 grams. Question 30. Solve the inequality x squared minus 7x plus 10 is less than or equal to 0. First, we find the roots of the quadratic equation x squared minus 7x plus 10 is equal to 0. We can do this by factoring method or using the quadratic formula. I'm doing this with factoring method. For doing this, first I multiply the coefficients of x squared, which is 1, in the constant term, which is positive 10. 1 times 10 is equal to 10. Then I write down all the factors of 10, which are 1 and 10, negative 1 times negative 10, 2 times 5, and negative 2 times negative 5. Then I need to find two numbers that when we add them together, we get the coefficients of x, which is negative 7. Negative 5 and negative 2 are these numbers. Minus 2 minus 5 is equal to minus 7. And I can write down negative 7x as negative 2x minus 5x. So I rewrite the equation as x squared minus 2x minus 5x plus 10 is equal to 0. Between these two terms, I can factor out x, and between these two terms, I can factor out 5. So between these two terms, it will be x times x minus 2 minus 5 times x minus 2. Then I factor out x minus 2, and I get x minus 2 times x minus 5 is equal to 0. When two terms multiplied together is 0, we set each of them equal to 0. So x minus 2 is 0, x is 2. X minus 5 is 0, x is 5. Now we need to do test intervals. We test the intervals created by the roots. Roots are 2 and 5. We'll choose test points within each interval to determine the sign of the quadratic expression. So we have three intervals: x less than 2, x greater than or equal to 2, and less than or equal to 5, and x is greater than 5. For x less than 2, I choose x is equal to 0 as a test point. So, and I replace x in our inequality with 0. So I get 0 squared minus 7 times 0 plus 10, or the result will be 10. 10 is positive, is greater than 0, so it doesn't satisfy our inequality. So this interval is false. The next interval is x is greater than or equal to 2 and less than or equal to 5. I choose x is equal to 3 in this interval. I replace x with 3 and I get 3 squared minus 7 times 3 plus 10 is equal to 9 minus 21 plus 10, and the result is negative 2, which is a negative number, is less than 0, and this satisfies our inequality. And the last interval is x greater than 5. I choose x, so this one is true, sorry. I choose x is equal to 6 for this interval, and I replace x with 6. I get x squared minus 7 times 6, sorry, 6 squared minus 7 times 6 plus 10 is equal to 36 minus 42 plus 10. The result is 4, which is a positive number and greater than 0. This interval also doesn't satisfy our inequality. So the inequality is satisfied when x is greater than or equal to 2 and less than or equal to 5. Therefore, the solution for this inequality, x squared minus 7x plus 10 is less than or equal to 0, is x is greater than or equal to 2 and less than or equal to 5. This is our answer. Question 31. Simplify this expression. 3 to the power of x plus 1 minus 3 to the power of x divided by 3 to the power of x plus 1 minus 3 to the power of 2x. First, we use this rule in the powers. So it states that a to the power of m plus n is equal to a to the power of m times a to the power of n. So I can write down 3 to the power of x plus 1 as 3 to the power of x times 3 to the power of 1. And I can write down 3 to the power of 2x as 3 to the power of x plus x, or 3 to the power of x times 3 to the power of x. So with applying this rule, I rewrite the expression. So 3 to the power of x times 3 to the power of 1 minus 3 to the power of x over 3 to the power of x times 3 to the power of 1 minus 3 to the power of x times 3 to the power of x. Then in numerator, I factor out 3 to the power of x, and in denominator also I factor out 3 to the power of x. So I get 3 to the power of x times 3 minus 1, and in denominator I get 3 to the power of x times 3 minus 3 to the power of x. I can cancel 3 to the power of x from numerator and denominator. 3 minus 1 is equal to 2, so our expression in the simplest form is 2 over 3 minus 3 to the power of x. Question 32. Solve this equation. Logarithm base e of x plus 4 minus logarithm base e of x is equal to logarithm base e of 4. To solve this equation, we will apply the properties of logarithms. There is a rule that says the subtraction of logarithms on the left side indicates division inside the logarithm. So it means logarithm base a of b minus logarithm base a of c is equal to logarithm base a of b divided by c. So I can rewrite this equation as logarithm base e of x plus 4 divided by x is equal to logarithm base e of 4. There is another rule that states that if logarithm base a of b is equal to logarithm base a of c, this means b is equal to c. So we can conclude in our equation x plus 4 divided by x is equal to 4, because both sides are the same base, and we need to solve this equation now. And for that, we multiply both sides by x, and we get x plus 4 is equal to 4x. Then I take x to the other side, and I have x is equal to 4x minus x, or 4 is equal to 3x. 4x minus x will be 3x. And if divide both sides by 3, I'll get x is equal to 4 over 3. Question 33. Given 4x squared plus 5x plus 6 is similar to a times x plus 1 squared plus b times x plus 1 plus c. Find the values of a, b, and c. I solved this problem using two different methods. In method 1, I try to change the quadratic equation for x squared plus 5x plus 1 into a form that can be written in terms of x plus 1. We know that a plus b squared is equal to a squared plus 2ab plus b squared. Therefore, x plus 1 squared is equal to x squared plus 2x plus 1. I replace 5x with 8x minus 3x, and also I replace 6 with 4 minus 3 plus 5. I will show you why I am doing this. So instead of 5x, I write down 8x minus 3x. And instead of 6, I write down plus 4 minus 3 plus 5. Now I rearranging it, and we write 4x squared plus 8x plus 4. I move 4 to here. Minus 3x minus 3 plus 5. Then I factor out 4 from the first three terms and negative 3 from these two terms. So I get 4 times x squared plus 2x plus 1 minus 3 times x plus 1 plus 5. Since x plus 1 squared is equal to x squared plus 2x plus 1, I can replace this with x plus 1 squared. So I'll get 4 times x plus 1 squared minus 3 times x plus 1 plus 5. Now comparing it with our expression, a times x plus 1 squared plus b times x plus 1 plus c, we can see that a is equal to 4, b is equal to negative 3, and c is equal to 5. I also solve this with another method. In this method, first I expand this expression. I expand a times x plus 1 squared plus b times x plus 1 plus c. X plus 1 squared is x squared plus 2x plus 1. So I'll get a times x squared plus 2x plus 1 plus b times x plus 1 plus c. Then I expand a and b, and I will get a x squared plus 2ax plus 1 plus a, plus bx plus b plus c. Then I rearrange it, so I'll get a x squared plus 2a plus b times x, 2ax, and bx will be 2a plus b times x, and plus a plus b plus c. Comparing the coefficients of the expanded expression with the coefficients of the given quadratic equations, 4x squared plus 5 plus 6, we get the coefficients of x squared here is a, and the coefficients of x squared in our quadratic expression is 4. Therefore, we can conclude that a is equal to 4. Then 2a plus b is equal to 5. 2a plus b is equal to 5. And a is 4. So 2a is 8 plus b is equal to 5. We take 5 to the other side and b to the other side. We take 8 to the other side. So b is equal to 5 minus 8. And 5 minus 8 is negative 3. So b is negative 3. We got the same answer. And a plus b plus c is 6. So a plus b plus c is 6. A is 4. C is negative 3. So 4 minus 3 plus c is equal to 6. 4 minus 3 is 1, plus c is equal to 6. I take 1 to the other side, so c is equal to 6 minus 1, or 6 is equal to 5. Question 34. If y is equal to 3 times ln of 2x plus 1, find x in terms of y. First, we take positive 1 to the other side and it will be negative. So we'll get y minus 1 is equal to 3 times ln of 2x. Then we divide both sides by 3 and we get y minus 1 divided by 3 is equal to 3 times ln of 2x divided by 3. Can cancel 3 on numerator with denominator. And we get ln of 2x is equal to y minus 1 divided by 3. Applying the inverse of the natural logarithms function, exponential function, to both sides to eliminate the natural logarithm. So we get e to the power of ln of 2x is equal to e to the power of y minus 1 divided by 3. We know that e to the power of ln of a is equal to a. So therefore, we have 2x is equal to e to the power of y minus 1 divided by 3. And if we divide both sides by 2, we get x is equal to 1 over 2 times e to the power of y minus 1 divided by 3. Question 35. Rationalize the denominator in expression 1 divided by square root of n plus square root of n plus 1. To rationalize the denominator of this expression, we'll use the common technique involving multiplying the expression by its conjugate. The conjugate of the denominator is obtained by changing the sign between the two terms. So the conjugate of square root of n plus square root of n plus 1 is square root of n minus square root of n plus 1. So to rationalize the denominator, we multiply both numerator and denominator by the conjugate of denominator. So we'll get square root of n minus square root of n plus 1 over square root of n plus square root of n plus 1 times square root of n minus square root of n plus 1. Applying the difference of squares identity from algebra, which states a plus b times a minus b is equal to a squared minus b squared. We get numerator will be the same, square root of n minus square root of n plus 1, and denominator will be a squared minus b squared. A is square root of n and b is square root of n plus 1. So will be square root of n to the power of 2 minus square root of n plus 1 to the power of 2. And we know that square root of anything to the power of 2 is that thing. So square root of n minus square root of n plus 1 divided by square root of n to the power of 2 will be n, and square root of n plus 1 to the power of 2 will be n plus 1, or square root of n minus square root of n plus 1. I expand this negative, so we'll get n minus 1. And we can cancel n with the negative n and apply this negative on the numerator, and we'll get 1 over square root of n plus square root of n minus 1 is equal to square root of n plus 1 minus square root of n. Question 36. Using the result of question 35, find the value of a is equal to 1 over square root of 1 plus square root of 2 plus 1 over square root of 2 plus square root of 3 plus 1 over square root of 3 over plus square root of 4, and until plus 1 over square root of 99 plus square root of 100. In question 35, we prove that 1 over square root of n plus square root of n plus 1 is equal to square root of n plus 1 minus square root of n. So for first fraction, 1 over square root of 1 plus square root of 2, I can, if I assume n as 1, I can write down this fraction as square root of 2 minus square root of 1. In the second fraction, if n is n, we assume n as 2, so it will be 1 over square root of 2 plus square root of 3 is equal to square root of 3 minus square root of 2. So I write down plus square root of 3 minus square root of 2. In the same, with the same reason, we can write down this fraction as square root of 4 minus square root of 3, and until the end, the last fraction, which I can write down square root of 100 minus square root of 99. Now we can cancel square root of 2 with negative square root of 2, square root of 3 with the negative square root of 3, square root of 4 with the negative square root of 4 in the next terms, and square root of 99 with negative square root of 99. We have a square root of 99 here. So then we have only negative square root of 1, positive square root of 100. So a is equal square root of 100 minus square root of 1. Square root of 100 is 10 and square root of 1 is 1. So 10 minus 1 is equal to 9. So this means that this our expression is equal to 9. Question 37. Solve the equation 25 to the power of x minus 5 to the power of x plus 1 plus 6 is equal to 0. For solving this, first we apply this rule that states a to the power of m plus n is equal a to the power of m times a to the power of n. So if we apply it for here, 5 to the power of x plus 1 is equal to 5 to the power of x times 5 to the power of 1. Also, we know that 25 is 5 to the power of 2. So we rewrite the equation as 5 to the power of 2 to the power of x minus 5 to the power of 1 times 5 to the power of x plus 6 is equal to 0. 5 to the power of 1 is 5. And also there is another rule that states that a to the power of m to the power of n is equal to a to the power of n to the power of m. We can swap the powers. So 5 to the power of 2 to the power of x is equal to 5 to the power of x to the power of 2. So I rewrite the equation 5 to the power of x to the power of 2 minus 5 times 5 to the power of x plus 6 is equal to 0. Now I use another variable and let u is equal to 5 to the power of x. So 5 to the power of x to the power of 2 is u squared minus 5u plus 6 is equal to 0. So we need to solve this quadratic equation now. First, I replace negative 5u with negative 2u, negative 3u. So I get u squared minus 2u minus 3u plus 6 is equal to 0. I factor out u from these two terms, u times u minus 2, and minus 3 from these two terms, minus 3 times u minus 2. Then I factor out u minus 2 and I get u minus 2 times u minus 3 is equal to 0. We have these two terms multiplied together is equal to 0, so we can set each of them independently equal to 0, separately equal to 0. So u minus 2 equal to 0 means u is equal to 2. We take negative to the other side, it will be positive, and u is equal to 2. But u is 5 to the power of x, so it means 5 to the power of x is equal to 2. And if we get natural logarithm from both sides, we get ln of x to the power, ln of 5 to the power of x is equal to ln of 2. And we know that there is a rule that we can bring this power to the to here, and ln of 5 to the power of x is equal to x times ln of 5. So x times ln of 5 is equal to ln of 2. And if we divide both sides by ln of 5, we get x is equal to ln of 2 divided by ln of 5. We have another terms to set to 0, set equal to 0. So u minus 3 equal to 0 means u is equal to 3, and means 5 to the power of x is equal to 3. Again, we take natural logarithm from both sides, and we get ln of 5 to the power of x is equal to ln of 3. And again, with that rule, we can bring the exponent to the front of the expression, front of the term, and we get x times ln of 5 is equal to ln of 3. Or we divide both sides by ln of 5, and we get x is equal to ln of 3 divided by ln of 5. Question 38. Solve the system of three equations. 2x plus y plus 3z is equal to 10, x plus 2y plus z is equal to 9, and 3x plus 3y minus 4z is equal to 11. We call these equations equation number 1, 2, and 3. We use elimination method to solve this system of three equations. In the elimination method, our aim is to eliminate one of the variables from the system of equations. Let's choose to eliminate z. In the first equation, the coefficients of z is 3, and in the second equation, it is 1. To make these coefficients opposites, we multiply the first equations by -1 and the second equations by 3. So first equations times -1 and second equations times by 3. We get, if we multiply both sides of this equation by -1, we get -2x minus y minus 3z is equal to -10. And by multiplying these equations by +3, we get 3x plus 6y plus 3z is equal to 27. Now we add these two new equations together. This -3z cancels this +3z, and we get 3x minus 2x, which will be x. 6y minus y will be 5y. 27 minus 10 is 17. So we have another equations with x and y. We eliminated z. So x plus 5y is equal to 17. Now we do the same process for between between equation 2 and equation 3. In equation 2, the coefficients of z is 1, and in equation 3, the coefficients of z is -4. So I multiply both sides of equation 2 by 4 and both sides of equation 3 by 1. So I get 4x plus 8y plus 4z is equal to 36. And multiply these equations by 1, I get 3x plus 3y minus 4z is equal to 11. Again, we add these two new equations together, and plus 4z and minus 4z cancelled from both sides, and we get 4x plus 3x 7x plus 11y is equal to 36 plus 11, which is 47. Now we have two new equations which has only two variables. So again, our aim is eliminate one of these variables. In equation 4, the coefficients of x is 1, and in equation 5, the coefficients of x is 7. So I multiply equation 4 with -7 and equation 5 with 1, and we get -5x minus 35y is equal to -119. minus 7 times 5 will be minus 35, minus 7 times 17 is 119. And we write down the equation 5 as is. So 7x plus 11y is equal to 47. Again, if we add these two together, negative 7x cancels positive 7x. Negative 35y plus 11y will be minus 24y is equal to minus 119 plus 47 is equal to minus 72. And if I divide both sides of this equation by negative 24, I get y is equal to 3. Then we substitute y is equal to 3 into one of the equations, say equation 4. So, and I get x plus 15 times 5y. Next, we substitute x. Next, we substitute y with 3 in one of the equations, say equation 4, and we get x plus 5y is equal 17, or x plus 5 times 3 is equal to 17. 5 times 3 is 15, so x plus 15 is equal to 17. We take 17 to the other side, and we get x is equal to 17 minus 15, or x is equal to 2. Then we replace x is equal to and y is equal to 3 in another equation, say equation 2, because it looks simpler. So we get x plus 2y plus z is equal to 9. X is 2, y is 3. So 2 plus 2 times 3 is 6, plus z is equal to 9, or 8 plus z is equal to 9. We take z 8 to the other side, and we get z is equal to 1. So the solution of this system of three equations is x is equal to 2, y is equal to 3, and z is equal to 1. Question 39. The area of the below rectangle is 91 square meter. Find the value of x. The length of the rectangle is 10 meter plus x, and the width of the rectangle is 4 meter plus x. To find the value of x, we can set up an equation based on the area of the rectangle. We know that the area of the rectangle is equal to length times width. So length is x plus 10 and width is x plus 4. So x plus 10 times x plus 4 is equal to area of the rectangle, which is 91. I expand the equation, so x squared plus 4x plus 10x plus 4t is equal to 91. I simplify and take the 91 to the first side of the equation, so I get x squared plus 14x plus 4t minus 91 is equal to 0. 4x plus 10x will be 14x. And plus 14 plus 4t minus 91 will be negative 51. So x squared plus 14x minus 51 is equal to 0. To find the value of x, we need to solve this quadratic equation. For solving quadratic equation, we have different methods. One method is using quadratic formula or delta formula, and the other method is using factoring. I use factoring to solve this. So for doing this, I multiply the coefficients of x squared, which is 1, with the constant term, which is negative 51. So 1 times negative 51 is equal to negative 51. Then I write down all the factors of negative 51, which are 1 times negative 51, negative 1 times 51, 3 times negative 17, and negative 3 times 17. Now we need two numbers, and when we add them together, we get the coefficients of x, which is positive 14. Negative 3 and positive 17 are those two numbers. So negative 3 plus 17 is 14x, and I can replace 14x with minus 3x plus 17x. So I rewrite the equation, and I get x squared minus 3x plus 17x minus 51 is equal to 0. Between these two first terms, I factor out 3, I factor out, sorry, x, and I get x times x minus 3. And between these two terms, I factor out 17, and I get plus 17 times x minus 3. Now I can factor out x minus 3, and I will have x minus 3 times x plus 17 is equal to 0. When we have two terms multiplied together equal to 0, we set each of them separately equal to 0. So we'll have x plus 17 equal to 0, or x is equal to minus 17. But since x represents length, we disregard this negative solution. So this solution is not acceptable. The other solution is x minus 3 is equal to 0. And this means x is equal to 3. Question 40. Solve the equation x cubed minus 6x squared plus 11x minus 6 is equal to 0. To solve this equation, we use STM or synthetic division method. We need to find the roots of the equation. Synthetic division method helps us test potential roots quickly to identify the roots of polynomial. We can start testing potential roots using synthetic division. We usually start by testing the integer factors of the constant term, which is 6, divided by the coefficients of the leading term, which is 1. So the factors of 6 is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. The potential roots are the factors of 6, or these numbers. We start with checking the results of equation by x is equal to positive 1 as a potential root. So I replace x with 1, and I get 1 cubed plus minus 6 1 squared times 1 squared plus 11 times 1 minus 6, or 1 minus 6 plus 11 minus 6. 1 minus 6 is minus 5, plus 11 will be positive 6, and positive 6 negative 6 is 6 minus 6, or 0. So x plus 1 is one of the roots of this cubic equation. We write down and this means our equations is divisible by x minus 1. So now we try to divide the equations by x minus 1 and find the other roots. First, we write down the coefficients of the cubic equation. So plus 1, minus 6, plus 11, and minus 6. Then I write here x is equal to 1 as a potential root, as a root actually. And I draw a line here. Then bring down the leading coefficient, which is 1. Multiply 1 by 1 to get 1 and write it here. Add the second coefficient, which is negative 6 to 1, and we get negative 5. Negative 5 multiply by 1 to get negative 5, write it here. Add the third coefficient, which is 11, with this negative 5, and we get positive 6. Positive 6 times 1, we get negative 6, positive 6 right here, and add the fourth coefficients with positive 6, and we get 0. When we get 0, it means that this is divisible by x minus 1, and we can write down the equation as x minus 1 times x squared minus 5x plus 6. Plus 1, positive 1, negative 5, and positive 6 are the coefficients of this quadratic function. Now we need to factorize this. We need to find two numbers that when we multiply them together we get positive 6, and when we add them together we get negative 5. Negative 2 and negative 3 are those numbers. So I can write down minus 5x as minus 5x as x squared minus 2x minus 3x plus 6. I factor out x from these two numbers and minus 3 from these two numbers. So I get x minus 1 times x minus 2 minus 3 times x minus 2. Then I factor out x minus 2 and I get x minus 1 times x minus 2 times x minus 3 is equal to 0. When we have three terms multiplied together equal to 0, we can set each of them equal to 0. So x minus 1 equal to 0 means x is equal to 1. X minus 2 equal to 0 means x is 2. And x minus 3 equal to 0 means x is equal to 3. So 1, 2, and 3 are the roots of this cubic equation. I hope you enjoyed watching this video. If you haven't already watched part 1 of the Ultimate Algebra exam, I strongly suggest doing so. Please consider giving us a thumbs up, subscribing to our channel, and sharing this video with your friends. Thank you so much for your support. Wishing you an absolutely fantastic time wherever you are on this planet.